Hi, my name is Takuzo Ganre. I am a former A-level student and I graduated high school with straight A stars, and I'm here to help you do the same. Or if not, just to help you make A-level maths a little less challenging. So today we're going to be learning about the discriminant. The syllabus point that we'll be focusing on states that we will learn how to find the discriminant of a quadratic polynomial ax squared plus bx plus c and use the discriminant. So if we have a quadratic in the form ax squared plus bx plus c, the discriminant is b squared minus 4ac. So this actually originates from the quadratic formula, which is x equals minus b plus or minus the square root of b squared minus 4ac over 2a. So if I can just highlight that, you notice that our discriminant is what's under the square root sign. So this is the discriminant, b squared minus 4ac. Now, when we talk of the discriminant, this is something that we use to determine the number of roots that a quadratic has, and it also helps us to determine the nature of those roots. So we have three possible scenarios where the quadratic has two real roots, or the quadratic has one real root, or it has no real roots. So let's start with the first scenario where it has two real roots. So if the quadratic has two real roots, b squared minus 4ac, the discriminant is said to be greater than 0. And when we sketch this on a Cartesian plane, you notice that the curve will intersect the x-axis twice. So this is an example of a scenario where the quadratic has two real roots. You can see that the x-axis intersects it twice. Now the second scenario is where we have one real root. It's also known as a repeated root. And in that case, the discriminant b squared minus 4ac is equal to 0. And when you sketch that, you notice that our x-axis will intersect the curve only once. And the third and final scenario is where the discriminant, rather the quadratic, is said to have no real roots. And you may hear this being referred to as it having imaginary roots. That is the same thing. It has no real roots, or it has imaginary roots. If a quadratic has no real roots, then the discriminant, b squared minus 4ac, is said to be less than 0. And when you sketch this on a Cartesian plane, you notice that the curve will not intersect the x-axis. Right, now let's apply this knowledge to some past paper questions. So the first question here reads, the line 4y equals x plus c, where c is a constant, is a tangent to the curve y squared equals x plus 3 at the point P on the curve. Find the value of c. All right, so we are told that the curve, rather the line 4y equals x plus c is tangent to the curve y squared equals x plus 3. So since it is a tangent to the curve, it means they only intersect once. And if we go back to the top, the scenario where the discriminant, where the curve intersects the x-axis once, we say that this means b squared minus 4ac is equal to 0. So we can go back to our question now. Here we know that b squared minus 4ac is 0. So to solve this question, since we're basically solving for a point of intersection, we solve them simultaneously first. So you come here, you have your two equations, 4y equals x plus c, y squared equals x plus 3. We'll make x the subject of the formula in the first equation, and we end up with x equals c minus 4y. Now substitute that x into the second equation. Now we have an equation where y squared equals 4y minus c plus 3. Now let's rearrange this equation and put all the terms on one side. And remember, we're trying to get it into the form ax squared plus bx plus c, right? So that we can deduce the values of a, b, and c and substitute them into the discriminant. So in this case, we can tell that our a here is 1, and then our b is -4, and c in this case is c minus 3, which is all highlighted here. We can now substitute that into the discriminant, substitute that, and you simplify. You should end up with c equals 7. So therefore, c is equal to 7. Now let's look at the second question. It reads, has equation y equals 3kx minus 2k and a curve has equation y equals x squared minus kx plus 2, where k is a constant. Find the set of values of k for which the line and the curve meet at 2 distinct points. We are told that the line and the curve intersect at 2 distinct points, which means that there are 2 real roots. And we know that in this case, b squared minus 4ac is greater than 0. So again, we'll start by solving the 2 equations simultaneously, since we're basically evaluating points of intersection. And so we have our 2 equations here, y equals 3kx minus 2k and y equals x squared minus kx plus 2. We equate them together and put everything on the same side. Then we simplify the equation to get it into the form ax squared. This should be equal to 0. Ax squared plus bx plus c equals 0. Then we can tell that a here is 1, b is -4k, and c is 2 plus 2k. Then we substitute that into the discriminant, and we should simplify and get a quadratic. We simplify, we end up with this quadratic. And if you factorize the quadratic, the roots that you get are k equals half and k equals 1. Now, to determine the inequality that you get, let's just sketch the curve. So our root here would be 1, and then here is -half, and this is 2k squared minus k minus 1. So since here we have a greater than sign, it means we want the region where the curve is above the x-axis. So that will be these 2 regions, which is k is less than -half and k is greater than 1. So that will be your final answer. K is less than -half and k is greater than 1. So that's all for the discriminant video. If you want access to these resources, I have left a link down below where you can access this PDF and even more resources on my website.